very smooth transition from what we're doing in the terms of support for different various kinds of ML tooling to one of the best forms of ML tooling out there today, which is weights and biases. And we're joined by Ryan here, who is, I first met when he was assistant professor at Bristol, but now he's gone to weights and biases and starting to have some additional kinds of impact. And he's going to talk us through how you can benefit from weights and biases, particularly in federated learning systems. So over to Ryan.
Great, thank you. Yeah, so today I'm going to talk about federated learning with weights and biases. For those who don't know, weights and biases is an ML ops platform. It's general purpose. Our customers and users use it for all sorts of machine learning workflows. But given where we are, I'm going to talk about some of the workflows we've seen with our current users around federated learning. So I want to motivate the use of something like weights and biases a little bit. I'm sure you've all seen this before. You're running experiments, you have results, you have configuration, you might copy and paste it from a notebook, a terminal, into some sort of document. You might do that over and over again. Or maybe you're more sophisticated and you use a spreadsheet. Now you have rows and columns for tracking your experiments and the results. Or maybe you are even more sophisticated and you use TensorBoard. So this is what I commonly see. And none of them are very good ways of doing machine learning. They're not very efficient or effective. When it comes to federated machine learning, because we have multiple clients, they all have their own loss plots. Here we only have 2 clients. It's already going to be difficult. But maybe we scale up to 4, or maybe we have even more clients. So at this point, we have so many results, so many experiments. How do we keep track of all of this stuff? And then people work in teams now in machine learning, right? So now we have each team member maintaining all of these things themselves. How do you collaborate? How do you get machine learning done effectively? How do you communicate the results? So maybe you have a Jupyter notebook. Maybe you send an email saying, hey, look at this strange result in cell 28. Maybe you post it on Confluence. Maybe you take, I see this often, maybe you take a screenshot and put it in this, PowerPoint and send that. Now you have a static image. Maybe you send it on Teams. Maybe you send it on Slack. I don't know. There's just so many moving parts here. And I think this kind of sums up a lot of machine learning workflows we see today. It's not fine. What we think the problem is, if you look at standard software engineering, every single step of the pipeline has really good tools, from designing interfaces to tracking code. We don't really have that for machine learning, even though it's much more complex, in my opinion, than developing software. We have text files, we have screenshots, we have all sorts of things that are unwieldy and don't really scale up to many users or many larger teams. So weights and biases is trying to fill that gap. So for the common tools needed for sophisticated machine learning workflows, we hope to fill those gaps. And you can get started in just a few lines of code. It's a Python package, pip install it. And really in 4 or 5 lines of code, you can start tracking your experiments, start organizing things, and start being more efficient. But as this is a Flower Summit, I wanted to give us perspective on some of the use cases around federated learning we have seen from our users and customers. In this example, we used Flower. We had different clients running in different infrastructure and different cloud nodes. We had servers, so it's fairly realistic. And I'm going to discuss some of the challenges we typically see. So for those who don't know, kind of the bread and butter of weights and biases was experiment tracking. That's kind of one of our many tools. And it lets you compare, contrast, investigate all of your experiments in an interactive dashboard. And this, live updates as your experiments come through. You can organize it in various ways. And some quotes there from some of our customers on how it's, driven their efficiency. But when it comes to federated learning, one of the key problems we've seen is around observability. Right? We have distributed clients. We can't really access them. We've no access to their data. We really want to know what they're doing, especially when you scale from just a few clients to many. Here we see in this workspace, we can divide out the different plots for the different clients. So we can see at a high level which clients are working well, which clients are not working well. And we can jump into any of those and see the hyperparameters, have a look at the pipeline to see where things might be going wrong. And of course, we have global metrics as well. So the point is we can organize our federated learning training in a much nicer way. One other thing we've seen useful is around system metrics. So the clients can be heterogeneous, right? There can be, some can have GPUs, some can not have GPUs. GPUs can differ. And we can automatically collect and monitor that system metric over time. So we can see how we can potentially, optimize machine learning workloads, seeing that maybe this is only using 50% of the GPU in one client. How do we improve that? And of course, we can spot and debug these things and group, filter, and search, so we can have a look and investigate the different types of clients in our federated learning scenario. Hyperparameter tuning is essential, really, for most machine learning workflows, squeezing those extra few percentage points out of whatever metric you're optimizing. But that becomes even more difficult in a federated scenario because, it's not just one model, one data set. It's potentially hundreds or thousands of models on hundreds and thousands of data sets. But we have functionality that's built in that connects to our system of record we discussed, keeps everything in one place, and allows you to scale out your federated hyperparameter searches across whatever scale you have available. We have some built-in strategies, some Bayesian search strategies to kind of do this more efficiently. And in the workspace, we can have some graphs that are already built in that lets you look at, for example, parameter importance for specific clients. So you can see which parameters are most important for which clients or maybe globally, and really helps you get a better insight into your federated learning workflow. And next up is something we see becoming increasingly important, which is around observability, auditability, reproducibility, and governance. So in a typical machine learning workflow, you have lots of different models, lots of different data sets. There's an explosion when you're doing federated machine learning, because what you have is, in a single experiment, many different models, many different data sets that you want to keep track of. You want to see how they connect. They all generate results. And with just a few lines of code, weights and biases can track, version, and give you these histories of lineage automatically. So you can go back, see, which results used which server. In this example, we have our server here. We can see which clients were involved in that. And we can see the artifacts that they've produced and consumed as well. And of course, given it's federated learning, we have some support for more privacy-enhanced ways of dealing with, data set versioning in your federated pipeline. One of the final things I want to say is around end-to-end training. So we want to kind of remove as much of the manual process as possible. And this becomes even more important in federated learning because there's more moving parts, right? You might have a server that depends on many clients using it. So when you want to launch an experiment, you need to launch the server, you need to launch each client. That can be monotonous, can be time consuming. So we have support for automating all of this in the proof of concept I made for this presentation. Upon starting an experiment, the server starts up, that starts up our clients across different infrastructure, different cloud nodes, and they all start communicating. That means with a click of a button or running a command, you can do these experiments much, much faster. We abstract away the infrastructure underneath. So we use Docker. We support Kubernetes. So your machine learning engineers, so people like me, don't want to deal with Kubernetes. They don't want to deal with all of that other stuff. And we support that. So we just package things automatically and let you focus on the machine learning and not the infrastructure. So I have two more points to end on. One is around collaboration. We're strong believers that's really important for machine learning. And it's built in throughout our product. Reports is a great one. So we can take all of these charts we've seen. They're live. We can put them in reports. And we can collaborate and share based on those. And finally, weights and biases is a system of record for all of your team's machine learning work streams. So, we're all about tracking all of your runs, your experiments, your models, your lineage, and we're used by individuals right up to hyper-growth startups to huge teams in Fortune 500 companies. So finally, we have a community. If you scan that QR code, you can join our Discord. Lots of ways of getting involved, lots of ways of getting help. And if you have any questions about the presentation or federated learning, please just reach out to me or speak to me here. I'd be happy to answer any questions. Thank you.
Thanks for the wonderful talk. Any questions from the audience? One from the back there.
Yeah, very interesting talk. I wanted to ask you about the federated hyperparameter optimization. What type of algorithms do you support? Bayesian optimization, genetic algorithms, or is there any backend that you're using for the federated hyperparameter optimization? How do you do it? That is the server the one that keeps tracks of the hyperparameters?
Yeah, so that's a really good question. So out of the box, we support 3 search strategies. The 2 you'd expect, random and grid search, but we also support a Bayesian search based on hyperband. In terms of how it actually works, yeah, it all goes through the federated server. So it communicates to all of the clients. So the clients ask it for the hyperparameters, and they'll take those and do the run. So it's seamless effectively. You don't really worry about the mechanics of it. Anything further? With that, let's thank Ryan again. Thank you very much.